So an application of using a differential equation to generate a slope field is a problem that may look like this. So this is what you might be asked to do when it comes to slope fields, because really it's unrealistic to be asked to generate an entire slope field. We really need to use technology to generate the entire slope field. It's too much calculation to be able to do that realistically. So what you might be asked to do is you may be asked to start with your differential equation, and we can sketch in line segments of that slope field based on plugging in x and y for those different coordinates. So for example, if I plug in the coordinate up here, this coordinate is x is -4, y is 5, I end up with -4 over 5 as my slope. So then what I would do is sketch a line segment with a slope of -4 over 5. So that's about -4 over 5. And then I move on to another point. So the next point here is -2, +3. So I plug in -2 for x, +3 for y, and then I get another slope. It's slightly less steep. Okay, so this one's a little bit steeper, and then we go to the next point, and I continue doing this. So for the next coordinate here, x is 0, y is 1. Okay, so we're going to end up with a slope of x is 0, y is 1. We get a horizontal slope. Sorry, that's going to be y is 0, x is -1. So we end up with, this is going to be, actually I'm going to write it down. It's going to be x is -1, y is 0. Okay, we're dividing by 0, so that's a vertical tangent here. And in fact, we're dividing by 0 here, so the vertical tangent here. Okay, and if I take a look at the other points, if I go to the right, okay, x is 4, y is 5. So in this case, we get the same slope but positive on the other side. So same thing here, we're going to get 2 over 3. In quadrant 3, we're going to get -2 over -3. So -2 over -3 is going to be positive. So it's going to give me a positive 2 over 3 slope. -4 over -5 is going to give me a positive slope like that. And then we can do the same thing in quadrant 4. So it's going to be symmetrical but opposite signs. So we basically get a graph that looks something like that. Okay, so we end up with these slope segments. And because these slope segments point at each other, we can maybe guess that there may be some solution that passes through these points like this. Okay, and so when we solve the general equation, we may get an idea. We should come up with an equation that might mimic this. In fact, this is a hyperbola. So when we solve this differential equation, so I'm going to separate this out. So I'm going to separate my dx's with x's, my dy's with y's. So I end up with y dy is going to be equal to x dx, integrate both sides, y squared over 2 equals x squared over 2 plus c. Okay, depending on the plus c, we're going to end up with y squared over 2. In fact, I'm going to do this. I'm going to multiply both sides by 2. So I'm going to end up with y squared minus x squared is equal to 2c, where the 2c represents the constant in the hyperbola. So in this case, we're going to get a hyperbola, either trans x or trans y. In this case, it looks like we have a trans x, so that 2c is likely going to be negative, but this is going to give us a hyperbola equation, and we can solve for the c by plugging in a coordinate in this, one of those slope field coordinates, and that would allow us to solve for the plus c, and it would very likely give us an equation that will pass through those points.